Alright guys, welcome back to our robot arm project. So today we're going to review a little bit about breadboarding, and we learned about resistance. We're going to build a circuit, but I'm going to challenge you a little bit in that, and then we're going to also look at buttons, which is a brand new thing. Alright, so first step, looking at the whiteboard here, let's go ahead and draw a circuit. Alright, and again I like to use the heart for the circuit, for the battery I mean. We're going to add a resistor, and then we're going to add an LED. I've done this a few times now, so I'm just going to speed through this. The plus will be 5V, the minus will be GND. And we went over which resistor was 470 ohm versus 4,700. I want us to use the 470 ohm resistor. And then this is the plus part and the minus part. So we got our breadboard here and then our Arduino here. I'm going to challenge us right now. I would like us to build this circuit that I've drawn here, but we only want to use 2 rows. So row 1 up here and row 2. Alright, so let me just write that, 2 rows. Alright, so a little challenge. So usually I won't say only use 2 rows, but today I want to, because as our circuit gets, or our robot gets more and more complicated, we're going to have to conserve space, okay? Because we're going to have to make all our connections on this one single board, and we got a lot of other stuff. So let's go ahead and do that, but on 2 rows. Alright, so let's first do the 5 volts connection. So going on here, let's stick it into 5V. This is a 5V, and I'm going to go row 1. Alright, and then we got to get our resistor, 470 ohm, that's going to be this one right here. Okay, it's the one without the red stripe. Let's go ahead and bend it. One side goes on the positive, or the 5V, and the other side is going to cross over to the other side. And now, if you guys remember, I mentioned last week, even though this pin and that pin, they're on the same row, there's no connection because they're on opposite sides of the valley. The valley is here. Okay, so just to say it again, this leg is not connected to that leg because of the valley, because the valley is separating. Alright, so then now let's go ahead and grab our light. Get our light. And then remember the plus, so the plus is the longer leg connects to that side of the resistor, and then short leg I'll put on row 2. Okay, looking good. And then let's do our last one, our GND connection. There, and then same row, there. Alright, I'm going to plug this in, make sure that everything's good. And my light has turned on. Excellent. Alright, now I'm going to go ahead and, so you guys go ahead and build this with me. Let's add some more resistance into this, and let's see what happens. So going back to my schematic here, I'm gonna do one of these. Let's erase that, and we're gonna add two 470 ohms. Alright, so we kind of went over this last time. The more resistance that we add to it, it means that there's more electricity that's going to be resisted, or more electricity that's going to be blocked. And if that's the case, the light should become dimmer. So let's go ahead and add a second resistor. All right, so how are we going to do that? Well, you could try to do everything over again, like take out all the wires, but then that might take a little while, or you can just modify what we have here. So I'm going to show you how to modify it, okay? So if I start from the 5V, looking at it, we have like the 5V right here. That's the same, and then we connect to a 470, so that's still good. And then right here, my breadboard, my actual breadboard has an LED next, but I don't want an LED. I want to put another resistor. So the best thing to do, guys, once you see something that's different, go ahead and pull the rest of it out, like that. Okay? So the first part's the same, and then let's go ahead and add the rest. Okay? So one side of the resistor needs to connect there to that, and then the other side of the resistor, let's try to use two. Let's see, I don't know, I might not be able to do it on 2 rows now because I added another resistor, but we'll see. Okay, so then that's my second resistor, and then now I got to connect my light. Ooh, actually I can do it in 2 rows because, let's see, the plus, which is the long leg, is going to connect here. So that connects to right here. And then my short leg, or the minus, is going to go across the valley. Okay. And then this row here, right now it's blank. The second row right here, I got to connect it to my GND. There. All right. So you may not be able to see it as well with the lighting and the camera, but it is slightly dimmer. Now let's make it super dim by changing out our resistors to the 4700. So I'm going to erase this now. And what I want now is 4,700, or I'm going to go fancy now. It's the same as 4.7 kilo ohm. Okay? Just a shorthand. It's the same thing. When I say 4.7 K, I mean 4,700, okay? All right, so then let's go ahead and pull, since we're doing this for the first time, let's go ahead and pull one out at a time so we don't get confused. So I take that one out. Like that. Okay, it's a little bit dimmer. And then let's take this one out and then replace it. It should get a lot dimmer. There. Again, you may not be able to see it as obvious in the camera, but when you do this in real life, you're going to notice it's a lot dimmer. And then, so before we move on, guys, let's look at this. We changed it from 470 and 470 to 4.7K and 4.7K. So what that means is, if we want to ask what's the total resistance, the total amount of resistance in this circuit, it's going to be these two added together, which becomes 9.4 kilo ohm, because 4.7 plus 4.7 is 9.4. Okay, so the interesting thing something we've learned here is that if you have 9.4 kilo ohm of resistance inside the circuit, this LED can still turn on. So that's good to know. We might need to use that fact down the road, okay? But I just wanted to point that out. So when we have 2 resistors like this, you just add them together and that gives you the total resistance. If you have 3 resistors, then you would just add all 3, okay? All right, so now that we've done that, I'm going to show you how to use this thing. right here. Okay, this is a button. I want you to take a look at the button, and I'm going to move this. I want you to take a look at the button, and I want you to notice that it has 4 legs. Now, what does the button do? The button allows us to modify the behavior of our circuit depending on whether or not we press it. And that's what buttons are used in robots or your iPhone or whatever. Should have a button either on the side or on the front of it. All right? Buttons allow us to interact with electronics. So they're a very important component for anything, really, for any type of electronic device. So let's figure out how this button works. All right, so I'm going to draw here. So going back to the whiteboard, I'm going to draw the button. Okay, so it's a box and a dot. And the dot here, that's where you press, okay? And you can try it. You can press, you can actually feel it press down and it pops back up. Now, there's a key thing that we need to first realize before we start playing with the button, because if we don't get this right, it's going to confuse us. All right, so if you look at the button closely, you could either turn it this way or that way. All right? This way or that way. Now if you look closely, okay, so I'm going to turn it this way. I'm going to call this horizontal, okay? If we turn it horizontal, and let's go back to the whiteboard, you're going to see the legs like that. If you turn it vertical, like that, you're going to see the legs like this. All right? I'm going to call this vertical, and I'm going to call this horizontal. Okay, now that we know there's these 2 ways to turn it, I'm going to do this. Okay? Do not turn it vertical when you're working with it. It's not that you can't ever get it to work when it's turned vertical, but what's going to happen is that in our class we're always going to have it horizontal, and if you have your button vertical, it's not going to work like everyone else's. Okay? So it's not like you can't get it to work, but then it's going to kind of, in a sense, be opposite from everyone. So let's make sure we turn it horizontal when we put it on the breadboard. Okay? So I'm going to do this. And I'm just going to place it. So why don't you go ahead and do this. Place it on the breadboard and make sure that it is horizontal. The legs are horizontal. And the way that I have it is that you see the 2 legs are on one side of the valley and the other 2 legs are on the other side of the valley. Again, it's got to be horizontal. If you try to do it vertical, it doesn't really work. See, the legs don't really stretch. You could probably force it, but then again, like I said, we don't want to do that because we're going to get mixed up. All right, so horizontal. Now that it's horizontal, let's go back to the whiteboard and I want to show you something. Okay, so we're going to have 4 legs, and let me change colors here. I'm going to call this leg 1A. This is leg 1B. This is leg 2A and 2B. All right. Now, if you notice, 1A and 1B, the number is the same. 2A, 2B, these 2 numbers are the same. The reason that I do that is that actually 1A and 1B, they are connected together. 2A and 2B, they are connected together. So regardless of whether or not you press the button, 2A and 2B are always connected. 1A and 1B are always connected. Okay? So you could probably think, well, what is not connected then? Well, 1A and 2A, they are not connected. 1B and 2B, they are not connected. So what happens, guys, is that when you press the button, so I'm going to do a dash. When you press the button, 1A, 1B gets connected to 2A, 2B. I'm going to repeat it just so we're all clear. When I press the button, 1A, 1B becomes connected with 2A, 2B. So why is this important? Well, the reason that we want this is that sometimes all the legs, they're not connected. And sometimes they are all connected. So what that allows us to do is actually create an open circuit sometimes and then a closed circuit sometimes. And if you're able to do that, you can turn your light off and on. Okay, so let me show you how this works. Okay, so going back to this circuit here with our 9.4 kilo ohm resistance. So I'm gonna modify it slightly. Okay. Let's take our button. Let's do this. And let's think about what's going to happen. All right? So if I build this circuit like this, I want to know if I don't press the button, is the light going to be on or off? So let's go ahead and draw in our 1A, our 1B, our 2A, and our 2B. All right, and because I already mentioned this, 2A and 2B, they're already connected, and 1A and 1B are already connected. So that's given. We don't have to worry about that. The only thing that changes is if we press the button. Okay, so my question was if we don't press the button, so I'll write it down here, or right here. If no press, what happens? So if I don't press the button, look, is there a connection from, my question is, here to here? If electricity is coming out and it's trying to get from here all the way through, like check it out. If you just followed it, it can travel through the resistors, through the light, and then to here, and then to this leg of the button. Can it get down to here? It cannot. It can't jump over because the button, there's a gap right here. It could go from here to here because this is connected, but then it would get stuck here, right? So it can't get there. Now, so let's write that. If no press, what would we get? No light. We could probably guess the opposite is true. If press, what happens? If I press, then that means a bridge is created, and then this electricity that was here can go here and then cross over through the bridge and then through. So if I do press, then we get light. All right, so let's build this circuit. Again, I want to teach us how to modify it so that we don't have to start over every single time. And so, as I mentioned, we go and then we start from the positive, and then we keep going to see what matches. If something doesn't match, then we take that thing out and everything after it. So let's do it. 5 volt, that's cool. Resistor number 1, 4.7K, that's in my schematic, that's cool. Second one, that's also fine. Then the LED, that's also good. So we're actually pretty good. So the LED all the way up to this point right here where my finger is, that's all fine. The only thing now is that we're missing this button here. So why don't we do this then? I'm going to take the G and D out because we need to add something. Okay. All right. Let's see if I can add this in. I'm going to take my button and I need to connect the 1A, 1B to the minus of the light. So I should be able to put it, I think I got it. The minus of the light is right there. So that's good. And then with the button, now 2A, 2B, they're down here on row number 4, I think. So 2A, 2B, I'm going to connect, it says 2A to G and D, but 2A is the same as 2B because those are connected. So that means I just need to connect to anywhere on this bottom row right here. So I think there's a hole right there. So let's stick this in. And once I push it in, will the light turn on or off? Well, if I'm not pressing the button, like going back to here, if no press, no light. So if I'm not pressing the button, even if I complete my circuit, it shouldn't turn on. Now, only when I press the button, I'm going to press now, then it turns on. All right. So there we go. So we got the button working. We learned about how to get this, how to work with the 1A, 1B, and 2A, 2B. And then we got the light going. All right, before I let you go, let's go ahead and create another circuit, but with 2 lights. So when I press the button, I want 2 lights to turn on. So I'm going to draw that right here. That. We have light number 1. And light number 2. Okay, now you might be asking, where's the resistor for this one? Well, what's nice about the parallel circuit is that this resistor can actually slow the current down enough for both LEDs. So you only need one resistor. All right, so we got these 2. And let's just make sure that this works. So I'm going to speed through this since we should be pros at this now. Let's take these out. Since so much has changed here, I'm just going to go ahead and take everything out. Okay. Okay, so I got 5V. Oh, I didn't say what resistance. Let's go ahead and say the 4.7K. Okay. Let's stick that in, 4.7K. Let's add a one light like this. make sure you can see here. And what we're doing here, see the plus of the second light. So maybe I should label this. I'm going to label the first light as LED 1, and then the second light is LED 2. Okay? So the first light, the plus, is connected to this side of the resistor. The second light, it's the same thing. The plus is connected to this side of the resistor. And then if you notice, the minus of the two lights, they're also connected together. So I can just make my breadboard reflect that. The plus is on the same row, and then the minus is on the same row. Very clean. Okay? Then the last one is the minus of both lights need to go to GND. So just stick this in. There we go. We got two lights. So two lights in parallel with one resistor. Cool. Now let's add a button, right? So where could we put the button? We could put the button right here. We could put it maybe right here or right here. So there are actually a bunch of different places where we could put the button. In this case, what we want it to do is we want it to turn off. We want it to turn off both lights if it's not pressed, and on if it is pressed. So when we press it, we want both lights to turn on. All right. Okay. So let's do this. So I'm going to say we should put it right here. Right here. So I'm going to go ahead and draw that in. And actually it does matter where you put it. But for now, I'm going to show you guys, let's get it so that both lights can turn on. And if that's what we want it right here. All right, let me get my eraser here and erase that. A little bit messy, but I think you guys can read it. It's clear what's going on here. All right. So let's go ahead and do that then. I'm going to take, I got my two lights here. I'm going to take out my GND. Take my button here. 1A goes like that. 1A, 1B row connects to the minus of both lights, and then the 2A, 2B row is down there, which is then going back to my schematic here. It's connected to the bottom row, or the GND, excuse me, the GND. Stick that in. Again, it's not on because I didn't press the button. If I press the button, both lights go on. Awesome. All right, so I'm going to pause there. Something that I want you to think about as we prepare for the next time we meet. So I'm going to just draw a little area here. Okay, so inside this red box, some things to think about. And if you want to go for it, you can also try to build it. Number one is how would you build a button circuit with 3 LEDs? So same thing that we did over here, but with 3 LEDs, okay? Number two, where would you put the button so that one light or one LED is always on. One LED is on only when you press the button. Okay, that's question number 2. So question number 1 is actually a little bit easier than question number 2. So this question number 1 is, how would I change this circuit here so that it works with 3 LEDs? Question number 2 is, how would I change this circuit here? And the hint is, where would I put this button so that one LED is always on no matter what, but the other LED is only on when you press the button. And then when you don't press the button, it's off. All right, so that's kind of like a brain teaser, a little design challenge. No worries if we can't get there. We're going to go over it together as a class as well. All right, that's all I got for you, and we will talk to you soon. Take care.